Greetings from the Hermitage and welcome to an introduction to the perfect square. The intent in this video is to give a visual reference to quadratic equations. A square is a right quadrilateral with four sides of the same length. In this case, the side length is the binomial expression x subtract 3, and the word binomial means two names or two parts. Now, a rectangle is also a right quadrilateral, but with sides of different lengths. In this case, the side lengths are x subtract 2 and x add 8. As a reminder, to get the area of a right quadrilateral, you multiply the base and the height. Now, you learn how to multiply two-digit numbers in the 4th grade. And this matrix method that I'm showing here of multiplying two binomials replicates a technique that most of us use. I'll give you a 30-second musical interlude so you can see how this works. And the technique works not just for binomials, but for polynomials of any size. When we come back, we'll graph the two quadratic equations that we derived here. Welcome back. Let's first look at the graph for the perfect square. When you graph a quadratic equation, you always get a parabola. And if that equation represents a square, the vertex will lie on the horizontal axis as shown here. Finally, the parabola crosses the vertical axis at the value of the constant term in the equation. You've heard it called the y-intercept, and in this case, for this equation, the y-intercept is positive 9. Let's now look at the graph of the rectangle. Looks very similar. The area of a rectangle can also be represented by a quadratic equation, and since it's a quadratic equation, you would expect to get a parabola just as you've shown here, and this is very similar to the square. For a rectangle, the vertex may lie either above or below the horizontal axis, and this is a major difference from the graph for the square. Just so you know, this would make a great exam question, one probably worth maybe 1 million, 2 million points. Finally, just as an example with the square, the y-intercept is the value of the constant in the equation. Okay, that's a lot of information. So let's summarize what we've seen. First, the areas of a square and rectangle can be expressed as a parabola, a quadratic equation. 2, the vertical intercept always has the value of the constant term in the equation. The vertex of the graph for the perfect square always lies on the horizontal axis. And in contrast to the square, the vertex of the graph for the rectangle may lie either above or below the horizontal axis depending on the equation. So with all that out of the way, let's see where we're going with this. The nice thing about a perfect square is that the equation is very easy to solve, and we'll show you that in the next video. But solving the equation for a rectangle is not so easy. But the perfect square has some special characteristics that help us with solving the rectangle. That'll be probably 2 videos from now. And in the next video, we'll look in detail at the perfect square and see what makes that perfect square so special. Thanks for viewing. And here at the end of the day, there's only one thing left to say, and that is, that's all, folks. Not forks, folks. Be safe. Con cuidado.